Oh, hi Putri, what are you doing?
Oh, hi chicken, I am eating grilled fish.
Can I sit here?
Yes, you can. I'm done. My head feel different again. Every time I eat fish, I am feeling pain and my finger feel a little numb. This cannot be normal again, chicken.
Oh Putri, I feel bad for you. Are you done right? Maybe we should go to our home first.
Yes.
But before that, I feel really thirsty. I want to refill my water bottle first. You want to come with me?
Yes, sure.
Let's go.
Wait, chicken, do you drinking tap water?
Oh, don't mind me. As you know, we in the end of our semester, so I'm trying to save my money. But after you mention it, I realized when I study, I cannot concentrate and I'm feeling very tired. Maybe it's because of water.
Maybe. No.
Wow! Oh, Putri, I forgot. I brought this antibiotic in case my pain gets worse. So after I hear your problem, maybe we should try this together.
Do you really think antibiotic will work for us, chicken?
We never know if we don't try. Oh no, it's already expired. Never mind, maybe I should just throw it into the drain.
Chicken, really? Don't throw antibiotics into the drain. That's dangerous. In MIC 125, we learned that when antibiotics enter the water system, they affect the natural bacteria in fibers and soil. That leads to antibiotic-resistant bacteria even in the environment. Next time, you should bring expired medicine to a pharmacy for safe disposal. Okay?
And you shouldn't take any antibiotics without prescription. Putri, I think your symptoms could be from liquid in fish. And chicken, I think it's from leak in the tap water. Antibiotic won't help with either one. We already learned that antibiotic only fight against bacterial infection. If we misuse them, it might stop working when we actually need them. So do you guys understand? Yes. Thank you guys for informing us.
We often think antibiotics are the solution to everything, but that's far from the truth. Heavy metal like mercury and lead can be treated with antibiotics. And using antibiotics wrongly or disposing of them carelessly only make things worse. In MIC 125, we've learned how microorganisms react to chemicals and drugs, and how easily resistant can be spread. This knowledge matters. It affects public health, the environment, and our future. So, be wise. Not every sickness needs antibiotics. Understand the cause and protect what can be seen.
What is antibiotics? Antibiotics is a substance produced by microorganism that is in small amounts to inhibit another microorganism. Antibiotics inhibit microbial populations by any 5 major methods. The first one is they disrupt cell wall synthesis. Second, they interfere with cell membrane function. Next, they inhibit protein synthesis or interfere with its completion. Other than that, they disrupt the functioning of nucleic acids. Lastly, they disrupt selected metabolic pathways. I think that's all from me.
Let's talk about the properties of an ideal antibiotic. An ideal antibiotic should only target harmful bacteria without damaging our body oneself. This makes it safe for the patient. It should not cause allergic reaction or trigger the immune system unnecessarily, because some people can develop rash, swelling, and breathing problems due to allergies. It must also protect our natural gut bacteria. These good bacteria help in digestion and immunity, so a good antibiotic should not disturb their balance. Another important point is that it should not cause antibiotic resistance. If bacteria become resistant, the medicine will no longer work to treat infection. Next, it must dissolve easily in body fluid, so it can reach the infected area quickly and act effectively. Its effectiveness should stay stable over time, meaning it won't break down easily after storage. Also, bacteria should not be able to easily become resistant to it. That way, the antibiotics stay useful for a long time. It should also have a long shelf life and not require special storage like refrigeration. This is especially helpful in place without cold storage. Lastly, an ideal antibiotic should be affordable so that everyone can access the treatment when needed. Now, let's look at the common side effect of antibiotic. The first one is diarrhea. This happens because antibiotic may kill not just harmful bacteria but also good bacteria in our gut. Bloating and indigestion are also common. Some antibiotics affect how our stomach works and cause discomfort. Stomach pain can occur too, especially when the lining of the stomach is irritated by strong antibiotic. Loss of appetite is another side effect. Some people just don't feel like eating when on antibiotic. Nausea and vomiting can happen, especially if the medicine is taken on empty stomach. Some people may experience itchy skin or rash. These are usually signs of a mild allergic reaction. Coughing and might also occur, depending on how the body reacts to the medicine. And finally, the very rare serious allergic reaction can happen. These include breathing difficulty and swelling, and they need help urgent medical help. So, even though antibiotics are powerful medicine, they must be used correctly and only when needed.
Let's begin by looking at what heavy metals are and why they matter, especially when it comes to mercury in fish. Heavy metals are elements that have high density and atomic weight. Some of them, like zinc and copper, are essential to our health in small amounts, but many others such as lead, cadmium, arsenic, and mercury are toxic even at very low levels. These metals are especially concerning in the environment because they don't break down. Once released, they can stay in soil, water, and living organisms for a long time. Industrial waste, mining, fossil fuel burning, and even certain fertilizer can all release heavy metals into the environment, eventually reaching rivers, lakes, and oceans. Among these metals, mercury is one of the most dangerous. It exists in several forms, but the one we're more concerned about is methylmercury, an organic form that builds up in fish. Methylmercury is formed when inorganic mercury is converted by certain aquatic microorganisms. Once it's in the fish, it's not easily eliminated. It stays in their tissues, especially in larger, longer living species like tuna, swordfish, and shark. As humans eat this fish, the mercury moves up the food chain, a process known as biomagnification. It's also worth noting that mercury used to be quite common in medicine and everyday tools. For example, it was used in disinfectant, thermometer, dental filling, and even some vaccines. This use took advantage of mercury antimicrobial properties. However, due to the known risk and long-term health effects, mercury is no longer used in food-related or medical products in most countries. Mercury is a heavy metal with serious environmental and health risks, especially when it enters aquatic ecosystem and transferred into methylmercury that accumulate in fish.
Mercury in water becomes a bigger problem when certain tiny microbes turn it into methylmercury, a more dangerous form. This version of mercury is organic, which means it's much more toxic and easily taken up by fish and other sea life. Once it's in the food chain, methylmercury builds up in fish like tuna and swordfish and gets more concentrated as it moves up. So, by the time it reaches humans through seafood, the levels can be quite high. But mercury doesn't just affect big animals. It also harms microorganisms, even the ones that help create it. It sticks to important parts of their enzymes and proteins, messing up how they grow and survive. Luckily, some microbes have a way to fight back. They use something called the MER operand with MER-A and MER-B genes. which help them break down or resist mercury's toxic effects. So overall, mercury can affect everything from the tiniest microbes to the fish we eat, making it a serious issue for the whole ecosystem.
Mercury pollution in aquatic ecosystem has serious consequences. It kills beneficial microbes and reduces microbiodiversity. This disrupts key nutrient cycle like nitrogen fixation and carbon cycling. As a result, fish health suffer, food chain dynamics are affected, and some microbes even develop resistance through genetic adaptation. For humans, the danger comes through contaminated seafood containing mercury. A toxic form built up in fish and is easily absorbed by the human body. It accumulates in organs, especially the nervous system and kidney. It is especially harmful during pregnancy. It can damage baby development brain. A tragic real-world example is Minamata disease in Japan, where people were poisoned after eating mercury-contaminated fish.
You can see the effect of consuming mercury-contaminated fish. So, mercury pollution does not just harm the environment, but it directly threatens human health.